Hello, and thank you for joining me today. My name is Dr. T, and I'm going to challenge you to be an engineer today. So you might ask yourself, what is an engineer? It's pretty simple, actually. Engineers love to solve problems. And what I'm going to try to show you guys today is that you're already an engineer inside. You just might not have had specific training for it, but you already know how to solve problems, because that's what we love to do. So I'm going to give you a problem, but before I get to that, we're going to play around with buoyancy. All right, so buoyancy is why boats float. And buoyancy has to do, when you put an object in water, say a ping pong ball, and you drop it into water, it floats, right? And the reason it does that is related to density. So density is the amount of stuff you've got in the volume, inside a volume. So the density of this ping pong is not a lot of density to it. Where if you take a golf ball that's the same size, roughly, it has a lot of density to it, much more. There's a lot more stuff. There's a lot more elements and molecules and things inside this golf ball than there is inside the ping pong ball. So when you put it into a bucket of water, guess what's going to happen? The golf ball is going to sink compared to the ping pong ball, right? So you can say, well, that's obvious because one's a ping pong ball and one's a golf ball, right? I got a towel here to keep things a little bit drier. So I say, all right, I'll challenge you with this. If I give you two oranges, they look the same, right? Smell the same. They're pretty much the same. If I put these in here, one sinks and one floats. Hopefully you guys can see that. I'll try to put it up there. So if you notice, I got one that sunk and one that floated. So you might be thinking, but how is that possible, right? So what I did actually is the one that sunk, I changed the density. Inside of it, I filled it with pennies. So inside this orange is a whole bunch of pennies. So when I added those pennies in here, it increased the density of this orange, which is why it sunk compared to the other one. The density has to do with that. Now buoyancy, why this guy floats, gets back to good old Newton, Isaac Newton, right? It turns out that one of his laws, the force of an object has an equal, if you push against something, it pushes back at an equal and opposite force. When I push this orange, it doesn't move, the amount I push on it is the amount that it pushes back. The same thing here. When I put this orange in the water, the pressure from the water actually is pushing back up on that orange and using that force to hold it, to keep it afloating. And if there's enough weight or mass to this, density to this orange mass to it, it will sink, right? So that comes back. So those kind of the key things related to buoyancy is you got your mass, right? How much something weighs, the volume of it, put those together, and that gives you your density. And that puts you down to your things. Now there's one other really cool property about water when you put an object into it, and it's called displacement. So displacement is when you put an object inside, if I spin this around, you should see a piece of tape, and that tape is roughly at the top level of the water. But when I put a larger object in there, you'll notice that the water increases in height. Hopefully you guys can see that. The water's actually moved above the line. That's because the volume of the object I put in has basically taken the space of that water and pushed it out. And that's called your displacement. And that can be pretty useful for if you wanted to figure out the volume of an odd-shaped object, say a banana. To figure out what the volume of this banana is, how much is physically here, it's a little tricky. But if we were to stick this into the water and measure the amount of displacement, which we know is easy to measure because we know the diameter of the circle and the thickness that it became, we can get that volume, and we know that that volume equals the volume of the banana. So displacement's a pretty cool technique and object you can use. So, I've been rambling a lot, but so going back to being an engineer or a scientist, right? So I'm an engineer by trade. I'm a mechanical and electrical engineer. I couldn't really decide which I liked more, so I kept on going to school. And now I'm actually a systems engineer on top of everything, so how systems work and how everything goes together. And I love to solve problems for that. So what I have for you guys is a problem. And this is a problem that you can do by yourself, you could do as a team, you could compete against your parents, your siblings, whatever you'd like to do. And it relates to that buoyancy, density, and displacement that I talked about. So my challenges for you to do is to do this. What you're going to need to collect is tinfoil, some sort of jar or container that's a decent size and diameter. You could use your sink, whatever can hold some water that you're going to play around with. And I need you to find a bunch of pennies, maybe 20 to 30, maybe 40, maybe 50 pennies, but a good chunk of pennies. All right, and you know what? You're dealing with water, so grab a towel. So what I want you to do is go ahead and pause this video and go collect those four things. So tinfoil, pennies, your bucket of water, and your towel. So go ahead and pause your video. Perfect. And now if you guys are back from the pause video, this is your engineering challenge. All right? What I want you to do is I want you to rip off. Oh, you know what? I forgot to tell you something. I need you to get a ruler too, right? So, a little side note, this ruler looks a little weird. If I put this right up to camera, you guys notice it's a triangle-shaped ruler? This is called an architect's scale or an engineer's scale. And it actually is pretty cleverly designed. Because it has 3 sides, it allows you to have a lot of different rulers on the edge, right? And the different scale, what they call scales, is sometimes it's broken up by 1-inch segments, sometimes it's broken up by 1/4-inch segments. And if you notice, there's actually 2 scales on each side. Because the triangle is not quite a true triangle, which has a kind of almost a spaceship feel to it, it allows you to have multiple rulers. So 2, 4, 6, this actually has 6 different rulers on it for 1 scale. And there's a little dimple in there because then it's much easier to hold if you're working on a piece of paper. You can slide it along the paper to draw your lines and work with it. So that's an engineer coming up with a better way to design a ruler for the application they have. And you guys would be surprised at the amount of engineering and science that is around you every single day. If I grab this pepper shaker or pepper grinder, right, it has some complexity to it. If you unscrew this little knob, and I'm pouring pepper all over the counter, there's a threaded knob in there, and if you open this up, and if you look inside there, there's pepper kernels. I don't know if you can see it. I'll take some out on my hand. The pepper kernels. And then in the bottom of this is a grinding shape. So there's actually teeth that go in there. And when you put this all together and screw it together, as you turn this, it grinds pepper. And depending on how far you screw this down, it changes the angle of the grinder to give you a different amount of flakes that you're grinding. So an engineer had to come up with this. But what's nice with this one, this is a wooden one that's been turned on a lathe. An artisan came in and made it look a little bit nicer, so you don't mind having it sitting on your dining room table to look at, and it's very functional for what it needs to do. And it has some function where if you want big chunks of pepper, you can leave the grinding wheel loose. If you want, you can tighten it down tighter, and then it will allow it to be a much finer grain. So an engineer had to do that. So if you look around your house, you will find things that the chair you sit in, everything, the cell phone that you used, an engineer touched and developed and helped create that product for you. And it took a lot of engineers to work together as a team, such as say mechanical or an electrical or different type of engineering, but also takes other careers and other professionalism, such as artisans, woodworkers for this guy, or different people who create this product. So sorry, little side note. But getting back to our challenge. So you have your tin foil, and let me move this pepper. What I want you to do is rip off approximately 12 inches of tin foil. And when you're done with that, I'm going to move the camera down. I want you to rip the tin foil into 4 pieces. So you can use the ruler to kind of hold and rip, and it should be approximately 6 by 6 when you're done. And if they're not perfect, they're not perfect. Don't worry about it. You guys can rip off more and play with more. But you should end up with approximately 4 evenly spaced pieces of tin foil. Right? You guys tracking? So your engineering challenge is, using this piece of tin foil, I want you to make a boat type structure to go into your water and see how many pennies you can hold up. So that's your challenge, is your knowledge that you just gained on buoyancy, density, and displacement to use this piece of tin foil and come up with whatever shape you want to create some sort of boat, floating object. It can't touch the bottom. You can't just make a pillar that goes straight down, because I know some of you are thinking about ways you can get around the rules, right? You're making some sort of free-floating boat that you can start adding pennies onto it and see how many you can get on there. So that's my engineering challenge to you. And what you're going to find is you've got multiple iterations. Design something, try it, see what worked, try it again, see what it worked, try it again, and see what worked. And work through all those different designs and see if you can come up with a boat that can hold, I don't know, 20, 30, maybe 40 pennies, right? So that's my challenge for you, and I hope you enjoyed this short little workshop. It's really fun being an engineer and scientist, and I encourage you to look into that path. If you enjoy solving problems like this one, I think you can always be an engineer and scientist, and you already are one. So build your boat. Here's my boat. I used a little bit extra tin foil. There's a Lego man in there because that's fun to do. It barely fits in here. And see how many pennies you guys can fit in your boat. Mine didn't hold up. Thank you again for taking the time to watch this video. I hope you had more success with your boat than I did. Please post pictures and let us know how many pennies you guys were able to hold up with your boat for everyone. And think about what it's like to be an engineer solving problems, because that's what you were as you built your boat. And I encourage you all to look more into other engineering and science opportunities to move forward. So thank you again. My name is Dr. T from Picatinny Arsenal, and keep on solving problems.